Welcome to the stream. This is your hacker Nikolai Zaya. Hello. Welcome Thomas Block. Welcome Andre. Welcome Quantum. Welcome Puffer. Welcome Tusha. Welcome Sebastian. Welcome Frank. 欢迎咪喵。Welcome Mr. Lucas. Welcome Sergey. Welcome Ransom. Welcome Singers. Welcome That guy, welcome Muhammad, welcome Yaya Brightcott, Yaya Brightcott, hello. Jacko, welcome, Slayer, welcome. Oh, welcome, Red, welcome. Atomi, welcome, Jamil, welcome. God, welcome, Rekai, hello. Ivan, welcome, yes. Today, we are learning Rust. We are going to discover if Rust is an object-oriented programming. And we're going to learn Struct. And associated functions that are called methods to see how to create new types in our programs. Good morning, warrior-san. Nikki, welcome. Welcome. It's super early for me, but I feel super excited. To start my day off with some Rust Struct. So let's start reading. Using Struct to structure related data. So Struct is to structure related data. And a struct or structure is a custom data type that lets you name and package together multiple related values that make up a meaningful group. So if you want to make your own type, you can use struct, like a student type, right? You can have a name and ID. If you are familiar with an object-oriented language, a struct is like an object's data attributes. In this chapter, we will compare and contrast tuples with structs. We will demonstrate how to define and instantiate structs. We will discuss how to define associated functions, especially the kind of associated function called methods, to specify behavior associated with a struct type. Structs and enums are building blocks for creating new types in your program's domain to take full advantage of Rust compile time checking. Yes! Let's go! Let's see. Hi Lily! Red Snake, welcome! 没有 skip 了吗？这么快吗？完全没有准备好。Okay, defining and instantiating structs. Structs are similar to tuples? Why? Because like tuples, the pieces of struct can be different types. Unlike tuples, you name each piece of data so it's clear what values mean. As a result of these names, structs are more flexible than tuples. You don't have to rely on the order of data to specify or access the value of an instance. What does this mean? Oh, the order of data matters in tuples because you can use index to access it. But in struct, because each data has a name, you can just access the value with the value name. Thank you, Batomi! Oh my god, it's so quick! I didn't even believe it when you guys said it was 4K. Is it really 4K? You guys are awesome! Thank you! Fast memory with Structs. Wow! So happy. So happy. Thank you guys. Thank you. Oh yes! We'll celebrate sometime. We'll celebrate sometime. By defining a struct. To define a struct, we enter the keyword struct and name the entire struct. A struct's name should be described the significance of the pieces of data being grouped together. Then, inside the curly brackets, we define the names and types of the pieces of data, which we call fields. So, we have a struct of name user and their fields like active, username, email, sign-in account. It stores information about a user account. But if I copy this over, what's going to happen? Main function has nothing, and we have a struct. We capitalize the name and use a lowercase for the fields. Thank you guys. Thank you. To use a struct after we define it, we create an instance of that struct by specifying concrete values for each of the fields. We create an instance by stating the name of the struct and then add curly brackets containing the key value pairs. That's so nice. Oh, like this. We create an instance by stating the name of the struct, which is user, and then add curly brackets and put the key value pairs in here. Let's try it. So we can declare an instance of user. Inside curly brackets, put the field. And comma, so many commas. It confuses me. At the beginning, when we put comma at the last field, I was like, why would we do that? And then I realized it's easier to add new stuff. Ah, it's comma. Okay, active, it's 2. And the sign in count equals to 1 and comma. 1 and comma. Can we print it? I don't know if we can print it. User 1. In my column. Go wrong. Oh, we need a semicolon there, and it doesn't want to print a struct because we need to implement this display method. Oh, makes sense. Comma is a great song? Why is comma a great song? Angling commas are usually a preferential thing. Some people like them, some people don't. We got a hater. For the record, the trailing comma is optional but conventionally put here when the struct expression spans multiple lines. So it's easier to add the new ones. Easier to parse. That glowing comma hurts my eyes. It hurts my eyes a bit too. We can put really? Oh, what? Does it just use debugs? Debugs display to display the user? Ooh, that's hacky. Derive. Debug. Like this. And then print line. A question mark. Would this work? Whoa. It worked! Wow, that's genius. Genius. Go. Don't do eternal sleep, Batomi. Stay with us. Yeah, we print out the struct, or the instance of the struct, by putting this at the top of the struct. The right seems like magic. It does. Thank you for the congratulations, you fun. Wait, what? At this? Just at the shop, I'll have a nicer output? Why? Ooh, it does look nicer. How does fast formatting work? Fast pink line format. Why did the shark work? Shark. Da, 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 da. What my team traits? Oh, question mark is debug? Warnings bad. How do I fix those warnings? Derive uses a special thing called a procedural macro. Structs also provided one to automatically generate code that formats your structure. That will be discussed later in the docs. Ooh! Derive is part of the macro system. It basically writes repetitive code for you. Nice! Nice. Okay, let me read more. Let me read more. We could use this whenever we wanted to use the value. We can get and set the value like this. If the instance is mutable, we can change the value by using the dot notation and assigning into a particular field. So, if this instance is mutable, then I can do user1 email goes to string from meow at meowstar.com. And if I print it, it's gonna show the email. It's gonna show the new email. Yay! We successfully changed a mutable instance. Note that the entire instance must be mutable. Rust doesn't allow us to mark only certain fields as mutable. As with any expression, we can construct a new instance of struct as the last expression in the function body to implicitly return that new instance. We can return a new instance in a function by constructing it as the last expression. Cool. Hello, welcome. I can put allow unused. Not allow unused. It suppressed the warnings. Oh, because we didn't use it, we only declare it. That's why we have warnings. Soka. Like this. Yay! What chapter is that? It's chapter 5, defining structs. Okay, next. A build user function that returns a user instance with the given email and username. The active field gets the value of true, and sign count gets a value of 1. So we can write a build user function with some default values in some field. Build user email is a string. Username is also a string. And we return a type user. And we write it as the last expression. Email is email. Username. It's username. And the active is true. Sign count is 1. So we could probably do that user2 equals to build user. It needs an email. Let's use user1's email. Haha, because I'm lazy. Username. Yeah. How about Cyan? This. Would this work? Yeah, we create a user Cyan. Why is my eyes shining? What happened? How? I got so excited. But how did I get back? I don't know how to get back. Okay, good. My eyes start to shine because I'm so excited for Structs. Okay, we have the build user. Oh, we have a shorthand. Let's see what the shorthand is. Oh, we can just put the names there. Like this. We can use the filled in neat shorthand syntax. It's so clean. Like it. Yeah, it runs no problem. So we don't need to say email equals to email. We can use the filled in neat shorthand. I guess it struck you as impressive. It does. Just handles redundancy for you. So nice. I like this user-friendly language so much. Creating instances from other instances with struct update syntax. It's often useful to create a new instance of a struct that uses most often all instance values but changes some. You can do this using struct update syntax. What? Struct update? So without struct update syntax, we use the string. We use the user one sign count, user one's fields. But we change the email. So with the struct update syntax. Oh, we can use the ... to say, hey, just use this guy's stuff. This is the best. This is like somebody passing you a paper of answers during an exam. So neat. Yeah, it reminds me of JavaScript's spread operator. I was thinking like, yo, I have seen this somewhere in React. Imagine being paid by line. What? Do people still do that? Boilerplate code, oh my god. So instead of using this build user, we can use the shorthand, the update syntax of struct. And my cat is here. Hello, cat. I can't see the example because you are here. Yes. From email at neonstar.com. And then we'll use the shorthand syntax user1. Your tail is onto something. Okay, good. Welcome, Don Don. So, would this work? Would this only change the email? Missing active. Wait. Oh, I deleted the shorthand, the spread operator. Oh, did you do that, cat? I think my cat did that. Oh, in my column. Unexpected token. Unexpected token. Works. It's using the new mail, but it keeps the same fields for user 1. Nice. exactly as it describes. Struct update syntax is like assignment with equal sign because it moves the data. It moves the data, just like we saw in the ways variables in data and data interact move section. In this example, what? We can no longer use user1 because after creating user2, the string in the username field was moved to user2. If we had given user2 the new string values for both email and username, and thus only use the active and sign-in values from user1, then user1 would still be valid after creating user2. Oh, so those two, they implemented drop. So if I borrow it from user1, if I take it from user1, I basically move it, so user1 will be invalid. So if I try to print user1 here, it's so tricky. Those of you who use Rust, does this cost you a lot of energy to think about? It says the value was moved here. So if I define my own email and username and then borrow it, this should work because active and sign-in count has the copy attribute. It still works. This is scary. Hello, teachers, welcome. Welcome, Scala, hello. Rust gave me the concept for a lot of new languages since syntax is similar. Like JavaScript. What is Conan? Okay, using tuple structs without name fields to create different types. What does this mean? Use tuple struct. Oh, you can use tuples to create types. You can also define structs that look similar to tuples, called tuple structs. Oh, what? The tuple and the structs gets married and produce tuple structs. What is tuple structs? Like this? Oh, it looks like a mixed paint. Tuple structs have the added meaning the struct name provides, but don't have names associated with their fields. Rather, they just have the types of the fields. Tuple structs are useful when you want to give the whole tuple a name and make the tuple a bit different type from other tuples, and naming each field, as in regular struct, will be verbose or redundant. Oh, so basically, it's a tuple. Struct. It's a tuple struct that doesn't come with names. Let's copy this example. Note that black and origin values are different types because they are instances of different tuple structs. The black and origin, they are not the same type. They are different tuple struct. Each struct you define is its own type, even though the fields within the struct have the same types. For example, a function that takes a parameter type color cannot take point as an argument, even though both types are made up of i32 values. Otherwise, tuple struct instances behave like tuples, You can destructure them into their individual places. You can use a dot followed by the index to access an individual value, and so on. So let's see this. We have a tuple struct of color, tuple struct of point. Color and point are two different things, so you can't say they are equal. And then we have black and origin, and black doesn't equal to origin. This is a nice example, and you can access individual indexes by using this. Just like in tuple. Let's try it. Cannot index into a type color. It says it can. You can destructure them to individual place. Oh. Let's do this. Ah, it worked. Yeah, I don't need a bracket. In that. Welcome, Louis. Thank you for subscribing. I realize my stream notification doesn't really tell me when there's newcomers. Welcome to Nelstar. You need like structs without any fields. You can define structs that don't have any fields. What? What's the point of it? These are called unit-like structs because they behave similarly to boom. What is this? The unit type that we mentioned in the tuple type section. Unit-like structs can be useful in situations in which you need to implement a trait on some type but don't have any data you want to store on the type itself. Ooh, okay. Here is an example of declaring and instantiating a unit struct named always equal. So we have a unit struct called always equal, and we have an instance of always equal. Imagine we'll be implementing behavior for this type that every instance is always equal to every instance of every other type. What? Every instance is always equal to every instance of every other type. Oh, okay. So it's saying that every instance of this unit struct is the same. And we want to do it for testing purpose. We don't need any data to implement the behavior. Basically a class without member variables, and with complicated syntax. Yes, it's just a struct with no fields, with no data. Ownership of struct data. In the user struct defined in listing, we use the own string type rather than the small string slice type. This is a deliberate choice because we want instances of this struct to own all of its data, and for that data to be valid, but as long as the entire struct is valid. Oh, so instance with the owned type will own the data. But instance without own type won't be owning the data, I think. empty inside. The struct just feels like me empty inside. But no, put some data in yourself. Borrow checker, man's worst nightmare. Does it get better with practice? It's possible for Struct to store references to data owned by something else, but to do so requires the use of lifetimes, a Rust feature that we'll discuss in Chapter 10. Chapter 10 sounds like a big challenge. Lifetimes ensure that the data referenced by a struct is valid for as long as the struct is. Let's say you try to store a reference in struct without specifying lifetimes, like this, which won't work. So we are trying to store a reference in struct without specifying lifetimes, like this. Like this? But it won't work. This crab looks confused. Why? Because he expected a lifetime parameter for a reference. So in the future we'll discuss how to use the reference types. No need to fear Cyan, only a man needs to fear the borrow checker. I don't know, this is genderly biased. Oh, borrow checker. An example program using structs. To understand when we might use structs, let's write a program that calculates the area of a rectangle. We start with a single variables and then refactor the program until we're using structs instead. Let's make a new binary project with cargo called rectangles that will take the width and height of a rectangle specified in pixels and calculate the area of a rectangle. Okay, how do I initialize a new project? Cargo new rectangles. I initialize it inside the variables. Yeah, bet. Move. I initialize it inside of folder. How do I move it to the parent directory? Okay. You didn't see that. Okay, so we have it. We have it. Rectangles. Source. Main. Yoshi. Can we just copy this over? Yes. I think in this case it wants to teach us that we can have a struct of rectangles with width and height as the fields. So we can even build a method for that struct. Let's go. VTuber vs Ball Checker is the best anime. Oh my god. I'll be nervous. Come on, Ball Checker, destroy me. What go wrong? It calculates the area. The issue with the code is evident in the signature of area. The area is supposed to calculate the area of one triangle, but the function we wrote has two parameters. The parameters are related but not expressed anywhere in our program, so it will be more readable to manage to and more manageable to group width and height together. Oh, they can do it by tuple too. They can do it by... Can they do it by tuple struct? I think so. Tuples don't name their elements and there's no sequence. So, we want a triangle, rectangle struct. Wait, it's supposed to be uppercase. Rectangle with it's an integer, height is an integer. So now instead of declaring width and height, we can do rectangle with 30, height 50, and in the function take the rectangle return rectangle width times rectangle's height. Supposedly it should work. Doesn't. Oh, what is this? Opening brace. Okay. So nice. It tells me I forgot a semicolon. Yeah, works! Our area function is now defined with one parameter, which is rectangle, and we want to borrow structs rather than take ownership of it. This way the main retains its ownership, retains its ownership, and we can still use rect1 afterwards. So we use this reference instead of passing in the rectangle. We want to avoid transferring the ownership. I like this compiler. So nice. The area function accesses the width and height fields of the rectangle instance. Our function signature for area now says exactly what we mean. Calculate the area of rectangle using its width and height fields. This conveys that the width and height are related to each other, and it gives descriptive names to the values rather than under the tuple index. It's a win for clarity! Yay! If you want to quit programming, then to read error messages in the C++. I know, it's always like, what was it? The index out of range, and what was it? The one about I forgot. But it happens so often in C++ error. It's like out of range, but it's like more severe than that. It gave me pain. Adding useful functionality with derived traits. Let's do traits. Oh, we want to print an instance of rectangle while we debug our program and see all the values. Also, we need to implement format display in order to print it, so this wouldn't work. In format string, you might be able to use this or pretty print instead. So this is pretty print. Ah, so here we're trying to print the rectangle, and we want to pretty print it, but to pretty print it, it needs to implement debug. Implement debug? Yeah, implement debug. Rectal 1. Oh, it tells us to put this above the struct to make it print prettier. We have to explicitly opt in to make that functionality available for our struct. To do that, we add the outer attribute just before the struct definitions. So this should work. It works. It prints the rectangle in a pretty way because it's a pretty print. Yay! Now when we run the program, it's just pretty. DPG macro. This macro occurs in your code along with resulting value of that expression, and then returns the ownership of the value. It prints the standard arrow console string. Standard arrow, which prints the... Oh, okay, it's error messages. I see. Do people use this macro? I mean, it's much shorter than print with pretty print. Because dbg returns the ownership of expression's value, the with file will get the same value as if we didn't have the dbg file here. We don't want dbg to take ownership of rect1, so we use reference to be dbg in next call. It's saying let's go equals to 2, and we put it around the expression of here. It returns the ownership of the expression's value, so the with file will just ignore this dbg. We don't want dbg to take ownership of rect1, so we put a reference here in the call. Okay. Thank you for subscribing. Repetitive emoton. My schedule is on my Twitter and Discord and Telegram group. I think I also have a schedule string that displays my schedule in my front page, so check it out. Yeah, it's a free chat room. Oh, and it worked. Did it work? It worked. It worked. This is the rectangle we are printing. In addition to debug trait, Rust has provided a number of traits for us to use with the derived attribute that can add useful behavior to our custom types. Those traits and their behaviors are listed in appendix. We will cover how to implement these traits with custom behavior as well as how to create your own traits in chapter 10. There are also many attributes other than derived. Okay, nice. We learned the dbg. Oh yeah. Riot of the Blood, thank you for subscribing. Welcome. Our area function is very specific. It only computes the area of rectangles. It will be helpful to tie this behavior more closely to our rectangle struct, because it won't work with any other type. Let's look at how we can continue to refactor this code by returning the area function into an area method defined in our rectangle type. Okay, let's go. Method syntax. We are moving the area function into the struct, right? Method syntax. Methods are similar to functions. They're declared with the function keyword and their name. They can have parameters and a return value, and they contain the same code that is run when they are called from somewhere else. However, methods are different from functions in they are defined within a context of a struct or enum of a trait object. And the first parameter is always self, just like Python, which represents the instance of the struct the method is being called on. The self is the struct. It is not the struct. Self is the instance of the struct. So what is this cool word? So it's not really defined inside the struct. You can. This is the normal function. course, that would be cool. That would be cool. Wow. Oh, I think there's a guy called Mario, and he already did an 8-bit version of my beginning 8 BGM. So if you want to reference the notes, you can see if you can find it. I think it's a YouTube video of 8-bit music shit. I really like explicit self. Self is a shorthand for self. Self refers to the type you are applying implement on. The explicit self is also good, since I feel any other way to specify readability will be pretty ugly. Say self 5 times fast. What? Self. Oh, I can't. Self. I did it. Okay. Okay, how do we do this? So, we use the keyword implement, rectangle, put it inside the curly braces. Boom! Oh, and then we don't need to have this big chunk. We can just do a reference to the self, and then self dot width times self dot height. So easy. So here, instead of calling that, it should be rect1.area. Oh, like this. Let's try. Yes, it worked. We calculate using a method instead of a function. Semicolon seems boring now. I'm very used to Python, and semicolon is something that I always forget. To define function within the context of rectangle, we start with an implement block for rectangle. Everything within this block will be associated with the rectangle type. We move the area function within the implement curly brackets and change the first parameter to be self in the signature. And now we can call the area method in our rectangle instance. In the signature of area, we use self instead of rectangle. The self is a short for self. Within an implement block, the type self is an alias for the type that implement big self is an alias for the type that the implement block is for. So it's rectangle. Methods must have a parameter named small self of type big self for the first parameter. Oh, so this is like an instance. And this is an alias for the struct. Oh, すごい. You can use semicolon in Python, it just ignores it. Thank you, Chris. Good luck. on your essay, Dong Dong. Thank you. We still need to use the reference in front of the self shorthand to indicate the method borrows the self instance, just like we did a rectangle. Methods can take ownership of self, borrow self immutably, as we have done here, or borrow self mutably, just as they can any other parameter. We've chosen a reference to the small self here for the same reason we used reference rectangle in the function version. We don't want to take ownership, and we just want to read the data in the struct, not to write to it. If we wanted to change the instance, we have called the method on as part of what the method does. We use reference mute self as the first parameter. So if we want to change the instance, we need to make it mutable. We need to borrow self mutably. Having a method that takes ownership of the instance by just using self as the first parameter is weird. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. So usually we do not just use self. Usually we want to borrow self immutably or borrow self mutably. The reason sometimes we use self only is when the method transforms selves into something else, and I want to prevent the caller from using the original instance after the transform. Do people really use it? We cannot overload in Rust. Oh, that's new. I use option. What is options? What is options? Rust. Option, std option, option values. Type option represents an option value. Every option is either some and contains a value, or none and does not. Oh. It's like a state in the middle. Option is nullable. Soka. Option is an enum, very useful and widely used in Rust. I can't wait to see it. The main benefit of using methods instead of functions, in addition to using method syntax and not having to repeat the types of self in every method signature, is for organization. We've put all the things we can do with an instance of a type in one implement block, rather than making future users of our code search for capabilities of rectangle in various places in the library we provide. So the methods being put in an implementation block makes it easier to organize all the methods of a struct. Now note that we can choose to give a method the same name as one of the struct fields. Oh, we can define a method name with. Does it return with? Oh, it returns true? So if we do another method here, implement rectangle function with x, a immutable borrow of self, and it returns a boolean self.with larger than 0. And if we do debug, I like this debug, it would be so useful. Debug struct1 dot with, it's gonna be true, right? Oh, what? What do they expect? I need a semicolon? Wait, what? For this one time, it doesn't give me the right arrow. Okay, nice. Yeah, we have the semicolon and then it returns true. It shows that we do have the with called the function. Oh yes. Return the value in the field and do nothing else. Methods like this are called getters, and Rust does not implement them automatically for struct fields, as some other languages do. Getters are useful because you can make the field private, but the method public. What? When did Rust has private and public? You can make the field private, but the method public. That's very OOP. And enable read-only access to that field as part of the type's public API. We'll be discussing what public and private are and how to designate a field or method as public or private in chapter 7. Ooh. Okay, so we can use a getter to return the value in an instance. Yeah, the stream is recorded on Windows, but VS Code is connected to a Linux server. You're right. Okay, where is the arrow operator? In C and C++, two different operators are used for calling method. Use dot if you call a message on the object directly, and use an arrow if you are calling the method on a pointer to an object and need to dereference the pointer first. In other words, if object is a pointer, object arrow something is similar to dereference object dot something. Rust doesn't have an equivalent. Oh, so this is a pointer operator? Wait. Anyway, oh, this is the operator for calling the method. I just call it arrow operator because it looks like an arrow. So Rust doesn't have the arrow operator. Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places in Rust that has this behavior. Here is how it works. When you call a method with object.something, Rust automatically adds reference mute, or dereference. The object matches the signature of the method. In other words, the followings are the same. we can put function with inside the implement with a function area. What? Really? But why? Wait, what? So we can we do this? Is that how people usually do this? Just like stay organized? Oh, it does work. Wow. So do you guys just put method into the same implement? So all the method stays in one place? That's so cool. That's so cool. Going back to this. The followings are the same in Rust. The automatic referencing behavior works because methods have a clear receiver, the type of self, given the receiver and the name of a method. Rust can figure out definitively whether the method is reading a reference to self, mutating, or consuming. The fact that Rust makes borrowing implicit for method receiver is a big part of making ownership ergonomic in practice. So once we define it correctly in the method signatures, we don't need to worry to dereference or do the pointer. Oh yeah, nice. Good work, Rust. I never need to think about dereferencing the pointers. It makes composition feels like inheritance from outside. Yeah, it's to check if the width is positive. Also in Rust, you can implement for concretive generic type. Ooh, what is that? Concretive generic type. I hope it talks about it later. Okay, methods with more parameters. Let's practice using methods by implementing a second method on a rectangle struct. This time we want an instance of rectangle to take another instance of rectangle and return true if the second rectangle can completely fit within self. Otherwise, it should return false. That is, we want to be able to write a program showing this. We want to write and can hold. So we want to implement a function here called can hold. It takes. Does it take two self? It takes another rectangle. It will take an immutable borrow of another rectangle as a parameter. We can tell what the type of the parameter will be by looking at the code of the method. And we only need to read the second rectangle. We want the main to take ownership of rectangle 2 instead of our function, our method. And the return value would be boolean. Oh. So the type, so we give it a name of other, and the type will be a big rectangle. And then we return a bullet. And you return if self.with is larger than other than .with, and self.height larger than other.height. If both of them qualifies, then it's true. When we run this code in the main function, we'll get the desired output. So, copy. Is this okay? I'll just remove those. Wait. Okay, let's see. Expected 1 of 8 possible tokens. Oh, what? What? Eh? Okay. Height. So many typos. To enforce. It worked. Oh, you can use other big self. Nice. Request the current rectangle as the self, and then the other. Specifying the type or not specifying the self will return the function into an associated function. In other language, you call this a static function. So we need to have the self to break it into a method on the struct. And this is an immutable borrow of a rectangle as a parameter. We can tell what the type of parameter will be by looking at the code that codes this method. So it takes an immutable reference to rect2. Yosh! Maria, welcome! So calm. Okay, let's go see the associated functions. All functions defined with implement block are called associated functions. So these are all associated functions because they are defined in the implement block. They are associated with the type name after the implement. They are associated with this type. We can define associated functions that don't have self as the first parameter, because they don't need an instance of the type to work on. Also, we don't have to have self as the first parameter, but that way they won't be method. They will become associated functions. Associated functions that aren't method are often used for constructors that will return a new instance of the struct. We already use for constructors to return new instance. For example, we could provide an associated function that will have one dimension parameter and use that as both width and height, thus making it easier to create a square rectangle rather than having to specify the same value twice. So, to create an associate function square size 32, it will return a rectangle. No, it doesn't have self. It returns a rectangle, so we initialize a rectangle. Width equals to size, height equals to size. So this is an associate function that returns a rectangle of the same width and height. A square. Where does the rectangle go? That's right, it goes in the square hole. Is that a meme? The meme was the puzzle. Where does the circle go? The circle goes into the square hole. So fun. So to call this function, we need to use associate. Wait, we need to use. Is that scope? Is that the namespace syntax? A square equals to rectangle column square. As a number, and we can also find out area. Yay! We get our rectangle. Wait, that is a square. We get our square by calling this. And then we get our area, 30 by 30. That square hole video. I know. Thank you, Warrior-san. Thank you. Woo. Thank you, guys. Where does the rectangle go? That's right, it goes into the square hole. So fun. Multiple implement blocks. Every struct are allowed to have multiple implement blocks. But there's no reason to do it. Oh wait, there is reason. In the later chapter, in chapter 10. I need to focus on chapter 10. Every fun thing is happening in chapter 10. We can actually replace both rectangle with self Oh, really? The big self. It stands for the type. Like this. But I don't think you can use here. Would this work? It works! So to make things easier, you don't need to write the name of the type of the struct. You can just use self, because self is rectangle. The big rectangle. There's so many selves everywhere. I know, so self-centric. I like the importance of certain future chapter becomes apparent by number of forward references to them. I like how he talks about things ahead a little bit. So when I finally get into the chapter, I feel more prepared. Yo, I've seen it before. Okay, summary. We learned about structs. Let us create custom types that are meaningful for our domain. By using structs, we can keep associated pieces of data connected to each other and name each piece to make your code clear. In implement blocks, you can define functions that are associated with your type and methods that are kind of associated function that let you specify the behavior that instances of your structs have. It's a long one, but let's break it down. In this block, we can define functions that are associated with my type, and methods are a kind of associated function. So methods are a kind of associated function that let us specify the behavior of instance of the structs. This is so clear. I like this explanation. So all of those are associated functions. Those with the small self are the ones that we can specify the behavior of instances directly. But structs aren't the only way to let you create your own custom types. Let's turn to Rust's enum feature to add another tool to your toolbox. Do you want to go ahead and learn about enum? Let's go! Chapter 6: Enums and Pattern Matching. I've been hearing about enums since I began this journey of Rust. So exciting. We can finally talk about it. Just make sure when you look at your code months later, you know what type actually is. I need some good naming and comments. The methods are also like ordinary associated functions, because you can also call them like rectangle area if you like, even with a self parameter. So we can use dot syntax because it's short, but we can actually do rectangle column method name. Ooh, すごい! Hello roommate, welcome! Hi bro, how's wife and kids? They doing good bro? How are you bro? Understanding ownership. What? Why am I suddenly chapter 4? We're on enums. Let's do enums. We'll look at enumerations, also referred as enums. Enums allows you to define a type by enumerating its possible variants. Whoa. First, we'll define and use an enum to show how an enum can encode meaning along with data. Next, we'll explore a particularly useful enum called option. which expresses that a value can either be something or nothing. Then we'll look at how pattern matching and match expression makes it easy to run different code for different values of an enum. Finally, we'll cover how the if-let struct is another convenient and concise idiom available to you to handle enums in your code. Options is the best type. Let's go. We're going to learn enums. We're going to learn its variants. We're going to learn how it can encode the meaning to the data. We're going to learn options, which is something or nothing. Then we will look at match expression and if-let. Enums are features in many languages, but their capabilities differ in each language. Rust enums are more similar to algebraic data types in functional languages, such as F#, OCaml, and Haskell. Waifus were dropped last year. Oh, poor waifus. Defining an enum. So when do we want to use enum? Say we need to work with IP address. Currently, two major standards are used for IP address, IPv4 and IPv6. These are only possibilities for IP address that our program will come across. We can enumerate all possible variants, which is where enumeration gets its name. What? Are we going to enumerate all of our IP address? That's insane. What do we want to do? Oh, it's not like that. Algebraic. We're in high school math now. Algebra 1, let's go. Any IP address can either be a version of 4 or version of 6 address. Okay. Wait, no. Version 4 or version 6 address, but not both at the same time. That property of IP address makes the enum data structure appropriate because enum values can only be one of its variants. Both versions 4 and version 6 addresses are still fundamentally IP address, so they should be treated as the same type when the code is handling situations that apply to any kind of IP address. So this feels like inheritance, does it? So we can define an enum of IP address kind, and the possible kinds can be v4 or v6. Now IP address kind is now a custom data type that we can use elsewhere in our code. We can create instances of each of the variants. The IP address 4 will be like this, IP address 6 will like this. Let me copy this over. Oh, this is a route function. We're gonna route the IP address, yo. This is dope. This is dope. So both of them are the same type, 4 and 6. They are all IP address kind. Define a function that takes any IP address kind. So we define a route, and we can call this function with other variant. We can call it with 4, with this variant or this variant. Why don't we put instance in there? Oh, because it takes... Wait. I think we can just do this. Will this work? Seems like no problem. That looks fun. Okay. So we have enum of v4 and v6, and now we can define the struct IP address. Struct IP address kind. Oh, we can use the IP address kind here, and we have address of string, big string. Let home equals to IP address kind. It's IP address kind v4 address is string from 1 to 7.0.0.1. This is the home IP address of IPv4. Let loopback goes to IP address kind equals to IP address kind with 6, and address equals to string from boom boom boom. What is this? Let's do it in the main function. Okay. Thank you. So we define IP address with 2 fields, kind and address. And we have 2 instances, home and loopback. We use the struct to bundle the kind and address values together, so now the variant is associated with the value. So it's saying that this is associated with the value. We can represent the same concept in a more concise way using just an enum, rather than an enum inside a struct. By putting data directly into each enum variant. What? So what has been changed? Oh, what? So instead of defining this struct, we can just define an enum and put data directly into the enum variant. like this. And then now home equals to type v4, and then we put the string of our address. Does any other language do that? Loop back IPv6. Boom. Oh, so this is the compressed format IPv6 loop back address looks like. It's the equivalent of this. Ooh, so cool. Ah, thank you. Happy ad. Would this work? Oh, this disappeared. This doesn't exist anymore. Can I print it? Is this how I do it? Look back. With semicolon. It's killing me. It's killing me. Rectangles. Oh, it cannot be formatted. I need to use that derive magic. Derive magic. Yeah. So it looks like it's a v4 of a string and it's a v6 of a string. Hi Mario, welcome. What is this BGM? It's a new BGM. It's this winter feeling BGM. So we attach data to each variant of the enum directly, so there is no need for an extra struct. Here is also easy to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of the enum. Whoa, that's a lot. What? We attach data to the variant of the enum. So we attach data to the variant of the enum. So we don't need a struct. And the name of each enum we define becomes a function that constructs an instance of the enum. So this is a function call, takes a string and return an IP address type instance. We get this constructor function automatically when we define enum. Okay, I must have seen this before. Which language has this too? Haskell? I think I've seen this before. Yeah. Is BGM allowed to remix? I'm not sure. It's allowed to be used, but I don't know if it's allowed for redistribution. I'm leaning towards it can't. And I don't own it, so... Okay. Nice, now we understand enum. It got variants, and we can call the variants to generate an instance of the enum. And each variant can have different types and amounts of associated data. Version 4 type IP address will always have 4 numeric components that will have values between 0 and 225. So it looks like U8 is 4. And version 6 will be a string. So here the enum can have different types. 127001. We have shown several different ways to define data structures to store version 4 and version 6 IP addresses. However, as it turns out, wanting to store IP addresses and encode which kind they are is also common, that the standard library has that definition we can use. Oh, so IP address has been defined by the standard library. It has the exact enum and the variants that we have defined and used, but it embeds the address data inside variants in the form of 2 different structs, which are defined differently for each variant. So I guess in the standard library there is IPv4 address and IPv6 address, and they all come from... They don't come from... They are in the signature of the v4 and v6 variant. So this is called embed address data inside the variants in the form of 2 different structs. Woohoo! I'm not sure if I have credit. I should credit. I feel so bad. There is freaking 50 people watching this stream right now. Holy cow. Thank you for watching. I didn't know there are so many people. Everybody loves Rust. Everyone wants to learn Rust too, exactly. Everyone likes programming strings. Yes, they do. Surprisingly, they do. Oh, thank you so much, Warrior. You're so sweet. You guys want another BGM? Let me try to find it. Oh, you guys are able to catch a stream. Oh yes, nice. Okay, for those of you who are curious about BGM, this is the BGM. Okay, that was a little break. Come back. This could illustrate you can put any kind of data inside an enum variant. You can put a struct. You can put string, numeric types, anything. For example, you can even include another enum. Also, standard library types are often not much more complicated than what you might come up with. Cool. Time to remove the C++ tag on my uniform? Well, if you look closer, this is not C++. It's a Sikusa. If you're into Japanese stuff, the two plus are connected together. It's like the character kusa in Japanese, which is like laughing, which is like I'm mocking the language, or the language is mocking me. It's not C++. I won't make myself copyrighted. It's Sikusa desu. Because I hated pointers. It's my first official language and I hated it. And C for Cyan too. Also my 私胸のサイズ. It's also my chest size. Sikusa. I think I have the best chest size in the entire world. Okay, enough joking. Even though the standard library contains a definition, we can still create and use our own definition without conflict, because we haven't brought a standard library definition into our scope. Oh, it's scope stuff. So we can have the same name, IP address that's in the standard library, because we haven't used standard library. Let's look at another example of enum. This one has a wide variety of types embedded in its variants. Let's see. We got a message. We got a quit variant, move variant, that takes... What is this? Takes... What? Takes two integers? This is not a tuple. Oh. A write variant that takes a string, and change color variant that takes an RGB value. Yeah, the move has a named field like a struct. Defining an enum with variants, such as ones listing there, it's similar to defining different kinds of struct definition, except that enum doesn't use the struct keyword, and all the variants are grouped together under the message type. The following struct would hold the same data that the preceding enum variants hold. So we declare this as if we're declaring structs. Like that. Triple structs, unit structs. But if we use different structs, each have their own type, we can easily define a function to take any of these kinds of messages, as we could with the message enum, defining listing, which is a single type. Because they are not the same type, so it's hard to write a function that works with all of them. To write a function that works with all of them, we need to put them in an enum. Magical. Do I have a GitHub account? I do. I have some projects. I had some projects on there, but I haven't touched it for a long time. Like, only VTuber related projects are in there. Hello, Tropical Fun! Welcome! If you want with different structs, you could use a union, but it's not recommended using Rust, especially if abstracted with enum. Yeah, just use enum. Looks very neat. My GitHub? I think it's cyan.com/GitHub. It is. It mainly has like my Minecraft information. Okay, next. There is one more similarity between enums and structs. Just as they are able to define methods on structs using implement, we are also able to define methods on enums. Here is a method called call that we could define on our method enum. Thank you， 谢谢冰喵，冰喵也好好休息，闭目养神，真的很晚了。Yeah, there is a Discord. cyan.com/Discord. So we can use implement to make a method for the type method, a function of call. What does call do? I don't know what does call do yet. A watermelon, why? So let m equals to message. Message write string from hello. So we use the write, and then we can do m.call. But what do you want to do inside the call? Like print line self dot what does message have? And also, why does the message has quit and move? The string of this doesn't have a name. I don't know what this is for. We'll be using match to differentiate the possible variants of the message we have. Let's move on. The body of the method will use self to get a value that we call the method on. In this example, we created a variable m that has the value message with a string. And that is what self will be in the body of the call method when call runs. So if I want to print this message, what do I do? Self will be message right. Oh, okay. Let's hope it talks about it next chapter. Okay, let's look at another enum in the standard library that is very common. Option. In the previous section, we look at how the IP address enum let us use Rust type system to include more information than just the data into our program. This section explores the case of option, which is another enum defined by the standard library. The option type is used in many places because it includes the very common scenario in which a value could be something or it could be nothing. The option type is used in many places because it includes very common scenario in which a value could be something or nothing. The option is for values that can be something or nothing. Expressing these concepts in terms of type system means that the compiler can check whether you have handled all the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages. Okay? So it's for bug preventing, and the compiler can check whether I have handled all the cases or not. Programming language design is often thought of in terms of which feature you include, but the features you exclude are important too. Rust doesn't have the null feature that many other languages have. Rust doesn't have null? What? Null is a value that means there is no value. In languages with null, variables can always be in one of the two states, null or not null. In his presentation, Null referenced the billion-dollar mistake. Tony Hoare, the inventor of null, has this to say: "I call it my billion-dollar mistake. At that time, I was designing the first comprehensive type system for reference in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a new reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years." So the inventor of null, Tony, wants to design a type system for references in all object-oriented language. He wants to ensure the references are safe, but he puts in a null reference because it's easy, and then it causes trouble. Have I figured out if Rust is OOP? What are the 4 concepts? 3 concepts of OOP? It is, I remember, polymorphism, inheritance. I don't think I see a real inheritance. implement multiple methods within the same class. Use the same name. And there's no overloading. So yeah, Rust doesn't have, the Structs doesn't have the inheritance. What is protocol-oriented traits? Oh, actually in chapter 17, it talks about if Rust is an object-oriented programming language. Looks like we still need to learn a lot to make the conclusion. So, but in short, under some definition, it is object-oriented. Under some other definition, it is not object-oriented. I think there is some encapsulation. But like Struct is a, I would say Struct is a similarity to the OOP languages. Okay, moving on. We're talking about new reference. About there shouldn't be a null at all to avoid errors. The problem with new values is that if you try to use a new value as a not new value, you will get an error or sometime. Because this null or not null property is pervasive, it's extremely easy to make this kind of error. However, the concept that null is trying to express is still a useful one. A null is a value that is currently invalid or absent for some reason. This problem isn't really with the concept, but with particular implementation. As such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option T, and it is defined by the standard library as follows. So we have an enum of option T type, and it has a type num and has a type sum. The option T enum is so useful that it is even included in the prelude. You don't need to bring it into scope explicitly. In addition, so are its variants. you can use some and none directly without option prefix. The option enum is still just a regular enum. And some T and none are still variants of the type option T. So they are called variants. This is the type option. They are the variants. Option has two variants, none and some, and you don't need the prefix because it's brought to the prelude. Included in the prelude. This syntax is a feature of Rust we haven't talked about yet. It's a generic type parameter, and we will cover generics in more details in chapter 10. For now, all you need to know is that T means some variant of the option enum can hold one piece of data of any type. And that each concrete type that gets used in place of T makes the overall option T type a different type. Each concrete type that gets used in the place of T makes the overall option T type a different type. So if we pass some T into some, it's going to make the option, or if we pass the type into option, option T will be a different type. So let some number equals to some 5. Let some string equals to some a string. Let absent number be this. So we have some number of 5, some string of a string, and an absent number a none. The type of some number is option I32. The type of some string is option string literal. String slice type, which is a different type. Rust can infer these types because we have specified a value inside some variant. Right here. For the absent number, Rust requires us to annotate the overall option type. So the compiler can infer the type that corresponding some variant will hold by looking only at the non-value. So because it is equal to none, the compiler doesn't know the absent number's type. So we need to put the type here. We tell the Rust the missing number is gonna be the type of option I32. When we have a sum value, we know that a value is present and the value is held within sum. Okay? When we have a null value, in some sense, it means the same thing as null. We don't have a valid value. So why is having option T any better than having null? In short, because option T and the type are different types. The compiler won't let us use an option T value as if it were definitely a valid value. For example, this code won't compile because it's trying to add an I8 to an option IN. So we have a b integer and we have an option ft integer, and we cannot add it up. We cannot add it up. Intense! In effect, this error message means that Rust doesn't understand how to add an I8 and an option I8 because they're different types. When we have a value of a type like I8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for null before using that value. Oh, So we don't need to check for null. Because if it's null, it wouldn't allow us to add. Only when we have an option I8 do we have to worry about possibly not having a value. And the compiler will make sure we handle that case before using the value. Nice! So what is this saying? So when we have a type like I8, compiler knows they're always invalid value. When we have option I8, compiler will check for us if it has a valid value or not. It forces you to check the option first before you can get X. Nice. So it's like helping us to eliminate more errors. In other words, you have to convert an option T to a T before you can perform T operation with it. Generally, this helps catch one of the most common issues with null, assuming something isn't null when it actually is. Not having to worry about incorrectly assuming a not null value helps you to be more confident in your code. In order to have a value that can possibly be null, you must explicitly opt in by making the type of that value option T. So if I know something could be null, we need to make the value option T. Then when we use the value, we are required to explicitly handle the case when the value is null. Everywhere that a value has a type that isn't option T, you can safely assume this value isn't null. This was a deliberate design decision for us to limit null's pervasiveness and increase the safety of Rust code. Woo! Option can contain something or nothing. You need to undo that operation before you can interact with the value. We need to take off the option to make sure it does have something. It's like a present. Gotta unwrap the box before you can get to the gift. Option is like a present. Schrodinger's cat in an option. Does it have a cat or not? Is it null or cat? In general, in order to use an option T value, you want to have code that will handle each variant. You want some code that will run only when you have a sum T value. And this code is allowed to use the inner T. So, if we want to use a value that's an option, we need to have code that handles each variant, which is null and sum. You want some code that will run only when you have a sum T value, and this code is allowed to use the inner T. You want some other code to run if you have a non value, and the code doesn't have a T value. T value available. The match expression is a control flow construct that does just this when used with enums. It will run different code depending on which variant of the enum it has, and that code can use the data inside the matching value. So when given an option, we will have sum and none. So when given an option value, we need to handle the sum case and the none case. And to do that, we can use match. The match control flow. The match control flow operator. You may or may not find a needle in a haystack, so the option needle may be a good type for the needle you are looking for. Option needle may be a good type for the needle you are looking for. Oh, the needle is wrapped in the present. You may or may not find a needle in the haystack. I might find some needle, and I might find none. I don't get any matches. What? Here you go. I'll give you a match that lights up. It might grant your wish. Switch case was better. Let's see. The match control flow operator. Rust has an extremely powerful control flow operator called match that allows you to compare a value against a series of patterns and then execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. Chapter 18 covers all kinds of patterns and what they do. The power of match comes from the expressiveness of the pattern and the fact that compiler confirms that all possible cases are handled. Oh, compiler will check that all cases are handled? That's so nice. I'll never miss a single case. Oh, let's learn this. Think of a match expression as being like a coin sorting machine. Coins slice down a track with a various sized holes along it, and each coin falls through the first hole it encounters it that it fits into. In the same way, values goes through each pattern in a match, and at the first pattern the value fits. The value falls into the associated code block to be used during execution. Because we just mentioned coins, let's use them as example. Okay, we can write an function that takes an unknown United States coin and, in similar way as the counting machine, determine which coin it is and returns value in cents, as shown here. Okay. Some match take patterns. Does it take special patterns? Like regress? Rejects? So we have a coin, penny, nickel, dime, quarter. How much is a nickel? 5 cents? Oh yeah. Oh, what? This is nice. So you use keyword match and you put the instance. And if it's a penny, it returns 1. If it's a nickel, it returns 5. If it's a coin, 10. If it's a quarter, 25. A pattern can be symbol number or enum type, but it can also do more like unpack structs and enums. It can check number ranges, it can check tuple layout, etc. Oh, number ranges, tuple layout. I wanna see them. There might be an example later. See you, Batami, thank you. And string slices too? Wow. What is playground communication? Oh. No output. Let's break down. The match followed by expression, which is the value coin, and then bunch of if else. Well, the difference is if needs to have a boolean value, but now here it can be any type. It just do a matching of the type. Match arms. Arm has a two part, a pattern and some code. Hot pattern and some code. The code in this case are just the numbers. Boom, 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 boom. When the match expression executes, it compares the resulting value against the pattern of each arm in order. Resulting value of the expression in the matching arm is the value that gets returned for the entire match expression. Oh, I can even take off the curly brackets? Oh. Never mind. It's just that, like, if I have big chunk of code, I can use curly brackets. Patterns that are bind to values. Another useful feature of match arms is that they can bind to the parts of values that match the pattern. This is how we can extract values out of enum variant. As an example, let's change one of our enum variants to hold data inside it. We wanna put data inside. No other coins got state designs, so the quarters have this extra value. We can add this information on our enum. What? What? Quarters has 50 states? Yeah, let's copy it. I never knew quarters has state behind it. New knowledge learned. Let's imagine that a friend of ours is trying to collect all 50 states quarter. While we sort our loose change by the coin type, we also call out the name of the state associated with each quarter. So if it's one our friend doesn't have, we can add it to his collection. In the match expression of the code, we add a variable called state to the pattern that matches values of the variant coin quarter. When a coin quarter matches, the state variable will be bound to the value of the quarter state. Now we can use state in code. Okay. Is it goes inside the implement? It doesn't go inside the implement. The value insert match. So here in the quarter it has a state and you print out the state. And then return 25. So if we call value in cents coin quarter Alaska, it's gonna print out Headquarters from Alaska. Hello, Sanitas, welcome. Headquarters from Alaska. Now let's handle the option T. How do we handle none? How do we handle no? We compare the variance of option T. But the way that the match expression works remains the same. Let's say we want to write a function that takes an option I32, and if there is a value inside, add 1 to the value. If there isn't a value inside, the function should return none, and not attempt to perform any operations. Let's write it. So we have a function of +1. It takes an option of type I32, returns an option of I32, match X, and if it's sum, it goes by sequence. So if it's, well, does it matter? I don't think it matters. It doesn't have a sequence. So if it's none, it's none. If it's sum, why does it switch to I +1? Let 5 equals to sum 5, and then if we put it into +1, let 6 equals to +1 5. Let none equals to +1 none. Debug. 6. Debug. None. Order is irrelevant? Okay. In this case. Oh, so 6 is sum 6 and none is none. They switch to I is because the match statement is destructing the value X to sum I. So I can't do sum X. So +1 5 goes here, and +1 none goes here. The I points to the value containing sum, so I takes the value 5. The code in the match arm is executed, so we add 1 to the value of I and create a new sum. And for none, it matches, and then stops and returns the none. Combining match and enums is useful in many situations. You'll see this pattern a lot in Rust code. Match against an enum, find a variable with the data inside, and then execute the code based on it. It's a bit tricky at first, but once you get used to it, you'll wish you had it in all languages. It's constantly a user favorite. Okay! Nice. And then about optional and match. Matches are exhaustive. What does it mean? Oh, the X will be shadowing that outer X. It does! Nice. But maybe you put I just to make it more clear. Matches are exhaustive. There is one other aspect of match we need to discuss. Consider this version of our +1 function that has a bug and won't compile. What's the bug? It doesn't have none case. So the code will cause a bug. Luckily, this is a bug Rust knows how to catch. Pattern none not covered. Rust knows that we didn't cover every possible case and even knows which pattern we forgot. Matches in Rust are exhaustive. We must exhaust every lost possibility in order for the code to be valid, especially in the case of option T, when Rust prevents us from forgetting to explicitly handle the none case. It protects us from assuming that we have a value when we might have no, thus making this billion-dollar mistake discussed early impossible. Yes. The Rust compiler will stop us if we don't completely cover all the cases, all the variants in an enum. Oh, birthday! We have a birthday person! Hello, Black TB, happy birthday! Happy birthday to you. Happy birthday to you. Happy birthday, Black TB. Happy birthday to you. Happy birthday. Have a Rust birthday. Catch all pattern and the underscore placeholder. What is this? Let's look at an example where we want to take special action for a few particular values. But for all other values, take one default action. Imagine we're implementing a game where if you get a value of 3 on a dice roll, your player doesn't move, but instead gets a new fancy hat. Okay? If you roll a 7, your player loses a fancy hat. For all other values, your player moves that number of spaces on the game board. There is a match that implements that logic, with the result of the dice roll hard-coded rather than a random value. And all other logic represented by functions without bodies, because actually implementing them is out of scope for this example. The cat is here hiding everything from me. Hello. Learn Rust with me, baby. Is that yes? So for the first two arms, the patterns are literal values 3 and 7. For the last arm that covers every other possible value, the pattern is the variable we have chosen to name other. The code that runs for the other arm uses the variable by passing it to the movePlayer function. This code compiles even though we haven't listed all the possible values U8 can have, because the last pattern will match all the values not specified specifically listed. This catch-all pattern meets the requirement that the match must be exhausted. Note that we have to put the catch-all arm last because the patterns are evaluated in order. Rust will warn us if we add arms after catch-all because those later arms would never match. So if we have other cases, put it at the end. Neat. Rust also has a pattern we can use when we don't want to use the value in catch-all pattern, which is the underscore. And it matches any value and does not bind to that value. This tells Rust we are not going to use the value, so the Rust won't warn us about an unused variable. Nice! So basically, if we don't want to do anything other than 3 and 7, then we can change it to underscore because we are not using the value. Nice! Now if we change the rules one more time, nothing else happens on your turn if you roll anything other than 3 or 7. We can express that by the unit value. Oh, there's a reroll. If really nothing happens, you can just use the unit code, unit value. Here we're telling Rust explicitly that we aren't going to use any other value that doesn't match a pattern in an earlier arm. And we don't want to run any code in this. Cool! That is match! So fun! And the last part of chapter 6, if and let. The if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. Consider the program listing in here. Option U8 value in the config max variable, but only wants to execute code if it's a sum variant. Hello, Mysterious K. So we have a config max. It's a sum variant, an instance of some variant. If the value is sum, we want to print it out. But if it's none, then we do nothing. Oh. If it's other, we do nothing. Okay. Oh, instead we can write this in a shorthand with if-let. So if it does have something, we'll print stuff. So I don't need to write this extra underscore syntax. The syntax if-let takes a pattern and an expression separated by an equal sign. A pattern and an expression. It works the same way as match, where the expression is given to the match and the pattern is its first arm. In this case, the pattern is sum max, and the max binds to the value inside the sum. Does it run anything? Does it do anything? Let's show. So the pattern is sum max, and the max binds to the value inside sum. So we can print the max over here. The code in the if-let block isn't wrong if the value doesn't match the pattern. Using if-let means less typing, less indentation, and less boilerplate code. However, you lose the exhaustive checking that match enforces. Choosing between match and if-let depends on what you are doing in your particular situation, and whether gaining consciences is an appropriate trade-off for losing exhaustive checking. In other words, you can think of if-let as a syntax sugar. Syntax sugar! Sugar! Yes, please! For a match that runs code when the value matches one pattern and then ignores all other values. So if-let basically matches one pattern and ignores all the values. We can also include an else with an if-let. The block of code that goes with the else is the same as block of code that would go with the underscore case in the match expression that's equivalent to the if-let and else. Recall the coin enum definition in the listing. The coin, where the quarter variant also has a US date value. If we wanted to count all non-quarter coins, if we want to count all non-quarter coins, while also announcing the state of quarters, we could do that with a match expression like this. So we have a mute count, and we match coin, and for the quarter, we print line the state. For other coins, we increment the count. Or we could use an if-let and else statement like this. Nice if-else. If you have a situation in which your program has logic that is too verbose to express using a match, remember that if-let is in your Rust toolbox as well. Cool! Easy peasy. So summary, we are done with the enums and match and if-let. We now covered how to use enums to create custom types that can be one of a set of enumerated values. We have shown how the standard library's option T type helps you to use the type system to prevent errors. When enum values have data in them, you can use match or if-let to extract and use those values, depending on how many cases you need to handle. So we learned how to use enums to create custom types. In the IPv4 and IPv6 example, we have learned option T that comes with some and none and helps us to prevent errors. And to do things with the types, you can use match or if-let to extract those values. Your Rust programs can now express concepts in your domain using struct and enums. Creating custom types to use in your API ensures its type safety. The compiler will make certain your functions get only the values of the type each function expects. In order to provide a well-organized API to your user that is straightforward to use and only exposes exactly what your user will need, we will go to Rust modules next time. We'll be learning modules, packages, crates, paths, all the cool stuff next time. So exciting. So exciting. Alright, that's the end of today's stream. Thanks everybody for coming to help. I really enjoyed this time. It's really happy to be able to make your own type in Rust. And it sounds like a very fundamental block to build some personal project. 研究部开下个教程啦，已经有点晚啦，吃个饭，然后歇着啦。Thank you guys, thank you Bellaware, thank you Warrior Song, thank you Lexing, thank you Icecan. For next stream is gonna be on my Thursday afternoon. I'll be drawing some anime girls. So if you like anime girls, come watch. And on Friday, I'll continuing on with the Rust programming tutorial. And on Sunday, we'll have a membership watch along of Ghibli's one of the famous movie, House Moving Castle. So if you are interested in that, join our membership. We'll have a watch along. Alright. Thank you, Yvonne. Thank you, Sergey. Thank you. I've seen Nightfall. Thank you, Tropical Fun. Thank you, Santas. I'll see you guys next time. Have a great day. Bye, Wanya. Bye bye. Good night, Tropical Fun. Have a nice day. Bye bye, Phil Dim. Bye bye, Sebastian. Hope you guys have fun.